All of you write the formula of SFW on time basis. So once you write the formula, just substitute the values. Is equal to mass flow rate m dot into bracket. So make a rectangular bracket after m dot. That is H2 minus H1 bracket complete plus V2 square minus V1 square V2 square minus V1 square divided by 2000. Now this is the turbine example of a turbine. So what about Z1 Z2?
0.
0. So I will not write that term Z1 Z2. So directly you can don't write that term Z1 Z2. So only this change in enthalpy and change in kinetic energy will be written. So here is the mass flow rate m dot. Now substitute the values. Whatever the data is given is equal to, so mass flow rate is given 17 kilogram per second, rectangular bracket. Then, so what is the H1 H2? H1 how much? What is H2?
360.
360. 360. Okay. Minus H1
1200.
1200. Correct. Plus V2. What is the value of V2?
50 square.
50 square. Correct. 50 square
Minus
50 square minus V1
160
square divided by 2000. Okay. Again, I think value of Q is also given. That is minus 2. You can substitute that. Minus W. So minus W. So make the calculation of the RHS terms, RHS values. Then take this minus to the right side. Answer. Make the calculations. Do the calculation. 360 minus 1200. Okay.
Minus 840.
Minus 840. Okay. Then plus make 50 square minus 160 square divided by 2000. How much is the value?
Minus 11.55.
Multiply by 17. So tell me final value here. सेपरेट कॅल्क्युलेशन केलं चुकणार लक्षात ठेवा. ह्याचं एवढे एकटाच एक कॅल्क्युलेशन करा एवढ्याचं, नंतर हे एवढ्याच कॅल्क्युलेशन करायचं आणि नंतर समेशन घेऊन त्याला मल्टिप्लाय बाय 17 करायचं. सो विल गेट द करेक्ट आन्सर.
Minus 1446.35.
Minus
47
6.35. Correct.
Plus 2.
नो +2 परत ऐड करायचे. After adding +2 or only what?
Only what? W minus 2 upon minus W is equal to.
Let's check it. Okay, -840, okay, and -11.55. If you multiply, then you will
सर +2 ऐड करावं लागतं अजून.
हाँ +2 ऐड कराते हैं. मग किती होते मग फायनली?
W is equal to 40,474.35 kilojoule per second.
Correct. Minus, that is plus ना directly. Here minus हे जर इकडे शिफ्ट केला तर मला वाटतं आन्सर काय, तर इकडचं +2 घेतला आपण ना. If you add +2, you will get -14474 ना.
Yes, sir.
Point
35.
35. Okay. So on the left side also minus. So minus get cancelled. So finally W is equal to 1,474,35 kilojoule per second. Na? Answer will be what? 1,474.35 kilojoule per second. This is the power developed by the turbine. This is the power developed by the turbine. So we can make rectangular bracket. Is it difficult? Is it difficult example?
No, sir.
There is like this. You can have the examples on this problems on SFEE. You may find this type of examples. So one homework I will give now. You have to try it. A steady flow thermodynamic system. A steady flow thermodynamic system receives fluid at the rate of 0.1 kilogram per second. 0.1 kilogram per second. Value is given 0.1 kilogram per second with an initial pressure of 2 bar. Initial pressure of 2 bar, comma, velocity 150 meter per second. Velocity 150 meter per second. And internal energy 800 kilojoule per kg. And specific volume 0.037 meter cube per kg. Full stop. The fluid leaves the system. The fluid leaves the system with a final pressure 8 bar velocity 200 meter per second, velocity 200 meter per second, velocity 200 meter per second, comma, internal energy 800 kilojoule per kg, and specific volume 0.25 meter cube per kg, full stop. If fluid receives if fluid receives if fluid receives if fluid receives 80 kilojoule per kg of heat, 80 kilojoule per kg of heat, 80 kilojoule per kg of heat, kilojoule of heat passing through the system, passing through the system, passing through the system, and rises through 60 meter, and rises through 60 meter, rises through 60 meter, comma, determine the work done, determine the work done during the process, determine the work done during the process, okay, determine the work done during the process, full stop. I will repeat the statement. A steady flow thermodynamic system receives fluid at the rate of 0.1 kilogram second with an initial pressure of 2 bar, velocity 150 meter per second, internal energy 800 kilojoule per kg, and specific volume 0.037 meter cube per kg, full stop. The fluid leaves the system with a final pressure 8 bar, velocity 200 meter per second, internal energy 800 kilojoule per kg, and specific volume 0.25 meter cube per kg, full stop. If fluid receives 80 kilojoule per kg of heat during the process, when it passing through the system, it rises by 60 meter, comma, determine work done, during the process, okay. Statement written. Hello.
Yes, sir.
Okay.
Yes, sir.
Now please read the example. Try to write given. Try to write the given data. काय दिले बघा. I think mass flow rate is given 0.1 kg per second. Okay, note down given data. Given mass flow rate 0.1 kg per second. Initial pressure is given 2 bar. Now convert into kilopascal. How much? How much is the kilopascal? Now they have given pressure in bar, 2 bar. So convert into kilopascal.
2000 kilopascal.
How much kilopascal?
200 kilopascal.
200 kilopascal. 200 kilopascal. Yes. Next. पुढचं काय दिलंय? Initial velocity v1 is given 150 meter per second. Next. Internal energy, specific internal energy is given at the entrance. Q1 is given 800 kilojoule per kg. Then V1, specific volume V1 is given. Specific volume V1 is also given 0.037 meter cube per kg. Specific volume. Then pressure P2 is given 8 bar, convert into kilopascal. That is 800 kilopascal. Velocity V2 is given 200 meter per second. Again, internal energy at the exit U2 is again same 800 kilojoule per kg. So U1, U2 is here same. Value of U1, U2 is same here. Next, specific volume at the exit, small v2 is equal to 0.25 meter cube per kg. The value of Q is given. Now here, whether Q will be positive or negative? Fluid ला heat तुम्ही external दिलेले आहे ना, त्यामुळे काय होणार? Is it plus or minus? Plus. Q will be equal to 80 kilojoule per kg. Small q. Whenever it is given in kilojoule per kg means it is small q, na? Per capital. Small q is equal to 80 kilojoule per kg. Then they are given. See, initially machine च्या सुरुवातीला काय असणार? Elevation datum surface ला Z1 ची value 0 असणार. Then it goes on rising. So that is what Z2 value, na?
Yes, sir.
So Z2 value is given 60 meter. And what about Z1? 0. Z1 will be equal to 0 and Z2 will be equal to 60 meter. Z1 will be equal to 0 and Z2 will be 60 meter.
सर
हाँ,
जी ची व्हॅल्यू कशी फाइंड करायची?
9.81 standard.
ओके.
Value of G standard 9.81 meter per second. Meter per second square, na? Standard value of G is 9.81, na?
हाँ.
You can take that value. Now, here we have to find out work done. So means what? Small w apply करायचं आहे ना? Here we have to find out small w. मतलब formula कुठला वापरणार आहोत? Mass basis का time basis?
Mass basis.
Use the formula. Write down. By applying SFEE on mass basis. By applying SFEE on mass basis. Right formula. small q minus small w is equal to into rectangular bracket h2 minus h1 bracket complete plus v2 square minus v1 square v2 square minus v1 square divided by 2000 plus g into bracket z2 minus z1 divided by 1000. Okay, bracket complete. Now substitute the values. Now here they have not given directly enthalpy, so you need to determine h1 h2. कैसे करना हम h1 h2 value? How to find out value of h1 and h2?
U1 plus P1 into specific value.
Correct. h1 is equal to u1 plus p1 v1 and h2 is equal to u2 plus p2 v2. Use these two relations. Okay, h1 there is one relation वापरा आणि find out करा h1 h2 value and substitute in the SFEE. h1 is equal to u1 plus p1 v1 okay. Similarly find out h2 also. h2 is equal to u2 plus p2 v2 okay. So find out separately h1 h2 values and then substitute in the SFEE on mass basis and tell me final answer. Here value of Q is given 80. Put the value as it is 80. Initial velocity v1 v2 is known. G value is 9.81. Z2 is known. Z1 is 0. So Z2 value is given 60 meter. Okay. So once you substitute the values, so tell me final answer.
$807.4.
Total.
No, sir, H1.
H1.
H1, okay. H1, yeah, yes, 807.4 kilojoule per kg. And H2?
1000.
Correct. H1 is 2 correct. Now substituting the formula SFEE on mass basis. So meantime, give the attendance. Roll number 1.
Present, sir.
2.
Present, sir.
3.
Present, sir.
4.
Present, sir.
5.
Present, sir.
6. 7.
Present, sir.
8.
Present, sir.
9.
Present, sir.
ज्यांनी प्रेझेंट दिलेले आहे त्यांनी सॉल्व्ह करत बसा किंवा ज्यांचा नंबर अजून आलेला नाही ते सॉल्व्ह करत बसा. मी ज्यावेळेस तुमचं नाव अनाउन्स करेल त्यावेळेस तुम्ही फक्त प्रेझेंट म्हणा. सो आय वॉन्ट दी आन्सर फायनली. ओके, रोल नंबर 10.
Present, sir.
11.
Present, sir.
12.
Present, sir.
13.
Present, sir.
14.
Present, sir.
15.
Present, sir.
16.
Present.
17.
Present, sir.
18. Roll number 18. 19.
Present.
20.
Present, sir.
21.
Present, sir.
22.
Present, sir.
23,
Present, sir.
24, 24, 25,
Present, sir.
26,
Present, sir.
27,
Present, sir.
28,
Present.
29,
Present, sir.
30,
Present, sir.
31,
Present, sir.
32, 32, 33,
Present, sir.
34, 34, 35, 35, 36,
Yes, sir.
37,
Present, sir.
38,
Present, sir.
39, 40, 40, 41,
Present.
42, 42, 43, 43, 44, 44, 45,
Present, sir.
46,
Present, sir.
47, 47, 48,
Present.
49,
Present.
50, roll number 50,
Present, sir.
51, 51, 52,
Present.
53,
Present, sir.
54,
Present, sir.
55,
Present, sir.
56, 56, 57, 58,
Present, sir.
59, 59, 60,
Present.
61.
Present, sir.
Okay, मी absent number वाचतोय once again. Roll number 6.
Sir, roll number 6 is present, sir. I have a network issue.
Okay, roll number 9. Roll number 9, 18, 24.
Hello, sir.
Yes.
Roll number 9 is present.
Okay, 18. Roll number 18, 24.
24 is present, sir.
Okay, 32, 32, 34.
Sir, present. 34.
Okay, 35, 35, 40, 42, 43, 44, 47, 51, 56, 59. These are absent. Okay, what is the answer? Calculated anyone?
Minus 121.938.
Correct. Minus 121.938. Correct. Kilojoule per kg. That is the work done. W is equal to minus 121.938 kilojoule per kg. That is answer. I will mention the answer here. W is equal to minus 121.938 kilojoule per kg. This is the final answer. Noted? अगर ज्यांचं झालं नाही त्यांनी कॅल्क्युलेशन करा. If you get this answer, then it is correct. Okay. Okay, we'll stop here. So maybe tomorrow we'll finish this chapter. Only that second law of thermodynamics. Okay, the statements of second law of thermodynamics are remain. So tomorrow we'll end this chapter. Okay. So what are the syllabus for ISC? Thermodynamic chapter complete. Huh?
Okay, sir.
Okay. ठीक है. So we'll conclude the meeting here. Thank you very much.